Okay, so let's make that circuit. So we have 5100, green output and ground. That's all there is. So that looks like a Thevenin equivalent. So we're done with that step. Now we can look at the high state. Okay. Under high state, here's 2.7. Okay. And this, of course, is 0. So I can figure out what the current is, and in this case, the output is coming out of the output terminal. Therefore, this is sourcing current. And remember, there's a limit on how much I can source on the output. All right, the limit is 0.4 milliamps. Okay, so how much is this sourcing? I can take a look at that. That's a simple calculation. Oh, it's really an H. So the high state output current in this case is 2.7 minus 0 volts divided by 5.1 K. When you do that calculation, you get 0.53 milliamps, okay, which is bigger than 0.4 milliamps. All right, you might be asking, what happened to the minus sign? Remember the whole purpose of the minus sign up in problem statement, minus 0.4? That's what told me that the limitation is from sourcing current, not sinking current. Okay, so this is sourcing more than 0.4 milliamps. Therefore, in this problem, this is bad. And we know right away the output specifications are going to be exceeded under the high state. Okay. So really, I could stop if I'm just trying to answer the question of whether this will work. It won't work. All right. But let's take a look also at low state. This is going to be 0.5 0.5 volts. Okay. Remember the low state specifications were a limitation on how much sinking, how much current you can sink through the device. If that's 0.5 and this is 0 volts, there's not a problem here because this will be sourcing. And our limitation is on sinking in the low state. Okay, so there's not a problem really. Low state works out fine. It's the high state where I have some problems on the last condition. Okay, so that's the solution to this problem from the review exam.